this is the initial page for the CS EduPack. Here we have the introductory and the advanced category. In each one, we have different levels that let us know what is the topic we want to analyze. We chose the level 1, and this subject contains description and the key information of over 60 of the most commonly used materials. This data has been designed for introduction of all the materials as an entry. We are going to choose an aleatory material, so we go to metals and alloys. And there we are going to choose non-ferrous. So then we click on gold, and there we have a general description of this material, but also general properties, mechanical, thermal, electrical, optical, eco properties, and some supporting information that are the typical uses, but also links of the properties universe.
This is another application that we found in the software. We go to chart select, then we go to limit, and for example, we select mechanical properties. In here, we can find many properties, like for example, the Young's modulus, and we can see the modulus depending in the classify of each one. Then we can find also thermal properties, and for example, if we want to achieve some Young modulus, we put in apply, and the software is going to give us some materials that are in the range that we want, and it shows you the physical properties, mechanical properties, thermal properties, electrical properties that it can have.
About a new application of the software we found to create a new composite and get all the properties that this new composite can give us. First of all, we have to select level 3 eco design. Then we have to go to the synthesizer and select it. Then the sandwich panel, the balanced one. Then we browse a face sheet. We choose metals and alloys, non-ferrous to get the aluminum, the broad, the 7000 series. Then we got the 7075. Choose the T6, and get okay for the core. We browse a rigid foam. We selected the about a rigid. Then we select the polyvinyl chloride, the first one PVC, the 0.040. And then for the variables about the face sheet thickness, we remove and get 0.1 to 3, and the number of values we got 3. For the core thickness, 10 to 50, and the number of values we got 5. For the force, the load, we got a simply support and central load. Then on the face sheet, we got aluminum, and for the core PVC. Pulse and get the create. They are calculating and get complete one. Finish it and goes to the part of the left. Choose aluminum face sheet, and there will be all the properties, the physical, mechanical properties like Young modulus, yield strength, thermal properties, electrical properties, primary, and some nodes that are representing a yellow square with a lot of nodes. For a chart or represent, we have to select or define what have to chart. So we are going to select only the materials that we choose to our composite and our record. So we have to unselect all ones that are not interact with our composites, like is there show it. We have to unselect and only select the materials that we are going to interact for the chart. There we have to go like the last part, select only our aluminum and our foam. Then we have to pull chart, and we are going to compare with in the y-axis the flexural strength and the x-axis the density for no, and then we are there are going to appear the relation about our PVC and aluminum, and there we can know how they interact.
Now we're going to look for the Aluminium 6061 in the CESA-DUPAC database. We first click on metal, non-ferrous metals, aluminium, then we click on broth, and in 6000 series. Then we look for 6061 and we choose a random heat treatment D6, and CESA-DUPAC will display all information you could need about this material, mechanical properties, thermal properties, physical ones, and all kind of stuff. Also, you can look for processes in this database, and we are going to look for the sand casting process that we are going to work with in the next laboratory sessions, and we click on casting, then in sand casting, but you can find all kind of processes. Also, machining is one of important ones, and CESA-DUPAC will display a lot of information about it. Personally, I think that as a mechanical engineer, it's very important to have a very good database like CESA-DUPAC, and this content will provide us important information along the course and along our professional lives about materials. And for me, in my opinion, as mechanical designer, I find this very interesting because you can choose the accurate material in order to design any stuff you're in.
Well, in conclusion, I look the program CESA-DUPAC to a very important program about our topic, because you can solve a lot of time using this program, because you can create a model or something like that with the properties of the materials and not do it in the experimental way, wasting your time.
I think CS EduPac is a very useful program because with this you can predict how it's going to behave a specific material, and with this you can predict what are going to be the properties of this material. Also, I think it's very useful to compare the reality, because the reality with the theory.
I think that this program, this software, is very useful also as a student and as industry. But I think that these are responsible for us to know how to use it and how to manipulate it in order to apply in other projects that we have and also in the class.
As a team, we think CS EduPac is a very important program, not only for this topic, but also for our life. We think this is going to be a program that we are going to use in the industry, or when we work. So we think this program is going to be very useful because it is a big database and we're going to use it in the project and in a lot of more projects.
I think that as a team, for example, if we want create some project that we need some requires for a specific material, this program can help us to find this material or to create this composite in order to satisfy this requirement.